So we should already be familiar with equations of a straight line, and we know the equation of a straight line since the beginning of graphs, and that's y equal to mx plus c. M is the gradient and c is the y-intercept. Today we're going to explore a more efficient equation for a straight line. Okay, and it comes from the fact that if we have some point on a line P, which is a fixed point, and A is a point anywhere on the line, right, which could change. Based on the fact that we have 2 points, we could calculate the gradient, and from that we could substitute one of the points in and calculate the y-intercept. So based on that, what we could say is that if we wanted to calculate the gradient, right, so gradient is equal to the change in rise over run. So the gradient would be equal to, and in our case here we have x and y and x1 and y1. So what we could say is we could have y minus y1 as our 1 point, or as our change in y. And on the bottom we could have x minus x1, just like we've always done before. Right, now what we're going to do a little bit different is we're going to multiply both sides by x minus x1 to bring it up to the numerator, and what we'll be left with is y minus y1 equal to m x minus x1, and this is the new equation that we're going to use when we want to work out the equation for a straight line. Okay, and so if you have a look at the equation, a standard equation has y equal to something x plus c, right? So here's our y and here's our x, right? And the other parts of the equation are the things that we need to find. So y1 and x1 is a point on the line that we need to substitute in, and m is the gradient as before. So either we will be given the gradient or we'll be given a way to calculate the gradient. So if we have basically a gradient and a fixed point, we can put it straight into this equation and we can calculate its equation. All right, so it's just a much more efficient way of working out the equation for a straight line. So let's look at how we would use this in practice. So here we have a question that says we have an equation and its gradient is 2 and passes through the point 4, 7. So we can use our new equation, y minus y1 equal to m x minus x1, remembering that we are substituting the point in here. Make sure you always substitute in brackets because it's y minus y1. We don't want to get caught out by double negatives, and we put the gradient here. So directly from the question we will have, this will be x1 and this is y1, so we can substitute straight in. So y minus 7 is equal to, the gradient is 2 x minus 4. So we can just expand and simplify, and so we'll get y equal to 2x, we'll have minus 8, add a 1, so we'll get minus 1. So it's just a faster, more efficient way of calculating the gradient of a straight line, rather than putting in m, substituting in a point, solving for c, and then putting it back into the equation. We're just going straight into the equation. So let's have a look at b and how we would work that out. Okay. So question B says we have a line and it passes through the following 2 points and we need to calculate its equation. Okay, so we aren't given the gradient. However, we have 2 points and all we need to calculate gradient is 2 points. So like before, we need to say this is point 1 and this is point 2. So we have x1 and y1 and x2 and y2. So to calculate gradient, we'll take y2 minus y1. So we'll have minus 4 minus 8. and we'll divide by x2 and x1. So we have 1 minus 5. And that's going to give us a gradient of minus 12 at the top, 6 at the bottom, and so we'll get a gradient of minus 2. So now we have our gradient. And since we have a gradient, we can select either of the 2 points to put into the equation. So we'll go straight there, and y minus y1 is equal to mx minus x1. So all we need to do is put in a point and the gradient, which we've just worked out. So I'm going to pick the point 1 minus 4, but it doesn't matter. You can pick any of the 2 points that you want. So here we're going to have y minus, and since this is minus 4, I'm going to put it in brackets so that I can see the double negative, equal to minus 2 x minus 1. So let's simplify. We're going to get y plus 4 equal to minus 2x plus 2. And so we can write this either as y is equal to minus 2x minus 2. Let's look at a more complex example, but using the same idea. So here we are told to find the equation of the perpendicular bisector of the line joining A and B. So we have 2 points, right? So we can imagine them as A and B. And we are looking to find the equation of the perpendicular bisector. So if we join the 2 points together, the perpendicular bisector is the point that splits the line in half, right? So that this part is equal to this part, and it does so at 90 degrees. All right. So in order to calculate the equation for a line, we need a point, and we also need the gradient. So the best thing to do would say, well, the common point between the 2 lines is going to be the midpoint here. And if I can calculate the gradient from A to B, I know that the perpendicular line's gradient will just be, if we multiply the 2 gradients together, I will get minus 1. So I can work it out like that. So we'll start off by finding the midpoint. So we know that the midpoint of AB is going to be equal to, and it's x2 plus x1 over 2, y2 plus y1 over 2. And so I can specify whatever one I want to be 1 and 2. So that makes this x1, and this is y1, and this is x2, and this is y2. And we can stick it straight into the equation. So we're going to get 7 plus 3 over 2. And we're going to get 10 plus 2 over 2. And that's going to give us the midpoint as 5 and 6. So that's the coordinates of the midpoint. And the midpoint appears on both lines. So now we have a point on our line that we're trying to calculate. Right, so from here, we need to calculate the gradient from A to B. So we can say the gradient of AB is equal to, and we know this is y2 minus y1 over x2 minus x1. And I've already labeled the point, so I can just go straight in. So we can go 10 minus 2 over 7 minus 3. And that's going to give me a gradient of 8 over 4, which is just 2. Now I want the gradient of the perpendicular bisector. So I know that if I take the negative reciprocal, right? So in other words, the gradient of the new line times by this gradient should get negative 1. So the gradient of the line I'm interested in is going to be minus 1 over 2. Right, now from here, I have the gradient and I have a point, and so I can go straight into finding the equation. So using y minus y1 equal to mx minus x1, I'll just substitute in the gradient and the point. So y minus 6 is equal to minus 1 over 2 x minus 5. What we can do is we can multiply the whole equation by 2. This will just make life a lot easier. And then generally what we'll do is we'll collect x and y on one side. So we'll get 2y plus x on the one side, and we'll move the 12 over to the other side and get 17. But this is all cosmetic. Generally, the question will specify to you which way it wants you to write the equation. So the takeaway from this lesson is this new formula that we use to calculate straight lines is one of the most important formula, and it's used throughout mathematics, especially when we start looking at tangents and something called the normal when we look at differentiation. So very vital that you understand how it works and how to use it.